Hello everyone, this is a video for our data mining project in University of Malaya. This is to document our milestone 2, which is to have a data lake for our data. So today, I will be implementing the standalone MinIO Datalake on AWS EC2 instance. To handle big data, we have two common file storage systems. One is HDFS, stands for Hadoop Distributed File System, which is based on block storage, while on the other hand, you have Amazon S3, simple storage service, which is based on object storage. I will not go into too much on differences between these two, but the take-home message is that according to databricks.com, S3 and HDFS, when compared, S3 has better elasticity, lower operating costs, as well as better availability and durability. This comes with some sort of trade-off on transactional rights. To follow along this video today, you need to have some knowledge on how to set up and access EC2. You also need to have some basic Python programming language knowledge. So without further ado, let me introduce MinIO. If you go to their website, which is min.io, they introduce themselves as the cloud-native data infrastructure, which is compatible with S3 object storage solutions. They have very good documentations, and I suggest you to take a look at it for all the different guidelines and quick start guide they have for different scenarios. But today, we will be deploying on EC2, so we'll take a look at how we set it up on AWS EC2. Here, I have 3 instances, but we are just going to use one. The important thing on this is basically you need to set up the security group so that you have the custom TCP port 9000 open so that we can access the data lake. The end goal of this is to basically have a data lake that we can access, put our data in, and also to pull and write this data into the data lake. And if you see here, we already have the data inside the data lake. But I will try to redo everything so that we get a clear idea on how to do it. Okay, now the first step is basically to SSH into our EC2 instance. So what we need to do is we need to copy the public DNS, put it to our PuTTY, and we need to select our authentication key. This is something that I have set up before. If you need help with it, you can look for online helps. And just to have like a 50 seconds duration for now packages to keep the session alive. And you can save this as MinIO demo. Okay, now we are ready to access. Now that we are in, we can go to the MinIO quick start and follow the guide. So we are using a Linux system. Basically, we will be copying the binaries, downloading the binaries from them. Just need to put this in. And wait for it to download. So there's a typo. There we go. Alright, this will take a few minutes. Okay, now that we are back and it's already downloaded, we just continue on with the rest of the commands. before that, we better set our new password. This is basically to not use the default access key and password. And then we need to make directory for the data folder. Change the ownership permission. Well, we'll see what it means. Change the permission. And it's ready to run. Okay, as we can see, it's running on port 9000. And what we need to do is basically we go there. So what we do is we copy the DNS for our instance. Go here, we put port 9000 here, and sure enough, we are in our data lake. So what we need to do is we just simply put the access key and secret key. So here we are in our data lake. So if you can see, there's no data right now, and what we need is basically to create a bucket for our data and upload all our data inside. I have already some script here. We basically need to change our EC2 address, change our access key and secret key. The rest should be alright. So the first thing to do is to declare our MinIO client by giving it the EC2 address and the port 9000. We have defined our access key and our secret key. We set secure to false simply because we do not want to use the SSH function. Okay, this needs to be string. And here we go. So to test the connection, simply try to make a bucket, and it should be reflected here. If you refresh this, see, we have a new bucket. So now that we know it's good, we know the bucket exists, we just go and remove it, and it should be gone. Okay, so now I have the folder with all my data inside. What I want is to basically upload all this data into the data lake. I have written a script here, which is basically just running everything. It's going to look through all the files in the folder, and we create a bucket for each folder, and the bucket name has to be a lowercase, so we set it to prefix.lower. So we will run this. As it is running, we should be able to see that let's see, it's not running. Yeah, it should be running. Okay, so here we go. We have all the folders here. I think it's a bit slow because it's doing a lot of writing currently. So yeah, we just have to give it some time. But as you can see, the data are being uploaded right now. And we already have 4 photos here. We should have one more, which is the weather data. Okay, so here we go. There is still writing, so we just take some time. So uploading the data to a data lake also depends on your internet connection, because essentially it's trying to upload the data to the EC2, which is on the cloud. But I think we should be done with it now. Yeah, so it shows an error. I'm not sure what it is, but let's take a look at it. Yeah, so it's just reading some hidden folder that is not supposed to be there. So it's fine. We know the error is good. Good. So basically we have all our folders here and all our files here. Okay. So what we need to do next is to basically see, this is how we list the buckets using the Python SDK for MinIO. And what we need to do is just to do a simple query to see if we can search for the file we need. So for example, if you want to look for the weather data, and with Indonesia and A as a prefix, so simply declare it here, and you can look for the files here. For simple SQL queries, you can also use the Amazon Web Service SDK for Python. So to do that, you just simply need to declare the S3, the bottle3 client. We set the endpoint URL and set the access key and secret key as we have done before. So we run that. For demonstration, we are using a simple SQL statement. So we say from the weather data, we want to select the day, location, and T. T is temperature. From the S3 object, which is a CSV we're going to declare later, and we want to bring out the temperature that are more than 20 in that CSV. So we declare the bucket. We say we want it to be from this file, and the expression type is SQL. The expression is basically the SQL statement we have here, and this is to basically say we want to use the file header information, and simply say this output serialization is from CSV. So this is just the structure on how we define to take the data. You can look for more information on how to run this on bottle3 documentation. And here is basically trying to convert the result from the call and convert it into a CSV-like format for the pandas to read it in CSV. So if you run this, you can see it was immediate. You get all the data where the temperature is more than 20 for this function. So that concludes my demonstration for this milestone 2. I hope you have learned something, and I look forward to see you again on next milestone. Thank you. Bye.